So, hi, Funds here. We're going to go over policy enforced pipeline controls, fine-grained controls to dynamic runtime policies, the implementation of policy control that we've done with Spinnaker. Spinnaker is the first integration we've done. We're going to do a couple more, but just to give you an idea of what this does and what it looks like. So the agenda is that we're basically going to go over philosophy with regard to continuous policy. What does it mean? What does it entail? What's the evolution of policy? What does it look like in enterprise? And what are the desirable outcomes of that? So we'll start off with change-driven versus runtime policies and audit-driven policies. Audit-driven policies is where people are mostly now, which means that an auditor comes in or there's some compliance question, people scurry around, gather information, an audit happens. It turns out that their governance is not in order, or they don't have the right policies in place, and they have to start like a half-year to a year project to put the right policies in place, which eventually is a cyclical thing and comes back seasonally because they get into the same mode every 3 years or every year or every couple of months, so many months, depending on what the cadence is of audits they get. This is very typical for financials, where you see that where there's this continuous cycle of audits that happen, and then basically things get found and they have to get solved, or somebody has to sign off on them, which is also a thing that happens, right? I mean, I have examples of that where people have HTTPS, a requirement to have HTTPS internally. It turns out they don't have HTTPS everywhere. Either someone signs off or they have to start a project to put HTTPS in place everywhere and then measure it for the projects they have. However, the next cycle, they'll get into the same problem and they'll continue this cycle inevitably endlessly. To solve this, people invented something like that was called change-driven policy. So every change that happens in the organization needs to be approved. It needs to go through a compliance check. Well, an example of this, if we look at pipelines and stages, if you create a new pipeline or a new stage, that would have to go through a policy check. What we're seeing is that people are, our competitors as well, are putting things in place that they'll check the ingress for Spinnaker, and we'll look at, hey, is the pipeline or the stage you're trying to submit, or are the stages you're trying to submit into the pipeline you're submitting, adhering to the policies that are defined from a larger governance structure. The difficulty with this is that means that if the policies change and a policy gets changed externally, this does not pertain to the pipelines that already exist until they are modified, which means that policies will go on executing and stages will go on executing without having any form of adhering to the policies that have been set. And as we know, policies do tend to change over time. Laws change, governance structures change, requirements from auditors or from a compliance perspective change due to regulations and regulatory requirements. So it's something that's in flux and needs to evolve with the organization, and so does the policy that is put upon the applications and application landscapes that are deployed and tools that are used. So as we can read here, there's no continuous policy enforcement when you're doing this. It's static, it's put in once. When it's modified, it's checked again. If it doesn't adhere, then yes, it will trigger, but it won't trigger on things that are runtime. Where we come in is runtime policy. So the previous change-driven policy is something we have a solution for. Our competitors have a solution for that, but for runtime policy, we've not seen a solution yet that is working, and we actually have a solution for that. What is a nice thing about runtime policy? Runtime policy means that if I trigger a pipeline or a stage runs, or before a stage runs or after a stage has ran, we can check if that stage has actually done what it's supposed to do, or we can direct the stage from not happening because it's not in line with the requirements that we have from a policy perspective. The nice thing about doing this with Spinnaker is that Spinnaker carries all of its input, output, and all of its context along with it continuously, which allows you to plug in at different places in the pipeline. So at any stage, or at the end of a pipeline, or at the beginning of a pipeline, or in the middle of a pipeline, I can inject a policy stage, and the policy stage will actually check if that at that moment in time the pipeline is in the state that we want it to be. This pertains to external resources. This pertains to internal components of Spinnaker. It pertains to everything. So the policy engine actually allows you to introspect those things and make a decision or a validation and then a decision based on the elements you're looking at. This allows you to actually move into continuous policy enforcement. The nice thing about continuous policy enforcement is that it allows you to move along with the morphing and the changing dynamic of policy itself and governance. This brings us to actually where we're going with this. Continuous multi-vector policy verification is something I called it. Dynamic policy verification is an interesting component. If we read scholarly, so there's a couple of articles out there that talk about policy enforcement, dynamic policy enforcement in security, and we're borrowing heavily from the notion of how these people think about it, because it is where the industry will go in a couple of years. And I think if we look ahead, that this is eventually where verification and policy verification will end up. So what we're basically doing is we're doing static verification of dynamic policies. So we define rule sets with which we prove with external and internal resources if the intent that the system has is correct or not. So it's runtime validation, it's real time, and the nice thing is we can plug in multiple elements that come together, and we can write rules for them that will actually enforce a policy that is based on a decision of multiple systems. Anyways, this is something that will evolve and will become more interesting and more relevant over time. So one of the use cases we recently were looking into is JSOX compliance. So this is a layout of a JSOX compliance question we received, and which we built out as a demo, the components that are in here. So if we look to the left, we see a GitLab, which actually is a source repository used by a potential customer, and they had certain requirements around what GitLab does. So JSOX has certain regulatory requirements where, for example, the person that creates the source code cannot and has and checked in the source code cannot sign off on the source code to be deployed. So there are certain regulations that the pipeline has to adhere to. The problem is if you do this in GitLab, GitLab itself cannot check itself if you've done this or not. So from a workflow perspective, it's ideal if I can trigger an external system to validate if the reality of what is the reality in GitLab is true or not, and based on that reality, so actively verifying and making a decision on that, saying, yes, we're within parameter of the policy, or no, we're not. I'm not going to continue with this exercise. I'm going to break off the pipeline. So this is what we built in a nutshell. So what we're looking at is a complete pipeline that ingests stuff from GitLab, checks with the policy service if everything is okay or not, does some QAing, wants some manual improvement, and then does some more policy checking, does something with some more release manager approval, talks to Jira, and then deploys a pipeline. That's in a nutshell what the requirement of this specific customer is.